Hello everyone. Today we'll be solving the problem number 1094 carpooling, right? So what the question states here, we are given trips of I, see here, this one I'm speaking of, just give me a second, 1 second. Yeah, trips of I we have been given. That is nothing but it consists of the passengers from and to. So this is nothing but the passengers come and from and to, nothing but passengers to from 1 to 5, right? So trips of I is nothing but the array. Within the array they have given passengers comma from and to, right? So indicating pickup and drop locations, right? So indicating pickup and drop locations, right? So we must return true if all the trips can be done without exceeding the car seat capacity. What we need to do, we must return true if all the trips can be done without exceeding the car seat capacity. Only we need to return true if all the trips can be done without exceeding the car seat capacity, right? So I have stressed this one thrice so that we remember this, right? So this will be helpful for solving the problem further, right? So the car only moves east, so you can't go backward to drop the passengers. We must simulate trip overlaps and track how many people are in the car at any point, right? So we must simulate trip overlaps and track how many people are on the car at any point, right? So just keep this in mind, man. Just keep this in mind. So this is fine. Next, now I hope the question part is completely clear, man. Right? So they have given us wonderful examples just for the sake of understanding, right? So now let's move on with the approach part. All right. Let's go with the approach followed by the complexities and then let's write the code as usual. First, initially, let's discuss the approach first. So here let me consider first example for the approach. So here we have 215337 and capacity we have been given 4, right? So we have to, so I'll just consider the first example. You can just try it out for the example 2 in the same way that I show for the example 1, so that you understand the problem better, right? So first let's sort the trips by from. Let's sort the trips by from, right? So here pickup point nothing but the trip A, pickup point nothing but the trip A and trip B they have given. So here trip A we have been given 215 and trip B we have been given 337, right? So 337 passengers from and to, right? So this is fine. Now we can just make use of the minimum priority queue. So we will be going with the minimum priority queue or the minimum heap. Just remember this one will be going with the priority queue, nothing but the min heap or the min priority queue, right? So to track the passengers who must be dropped by two location, who must be dropped basically, right? So at location 1 we'll be picking two passengers. At location 1 we will be picking two passengers. See here, this is passengers and this is what I said. So this is passengers, yeah, this is from and this is to, this is to, right? So at this one location 1, this is nothing but the from. At the location 1 we will be picking two passengers, right? So this will be total will be 2. So total initially let's consider this total equals 2 here, right? So total equals 2, this is fine. Next, at location 3 we drop nothing, so we drop nothing yet. At location 3 here, this one, at location 3 we drop nothing yet. We'll pick three more. So passengers we have three more right here. This one, this is nothing but the passengers. We will pick three more. Total equals 5. So total equals 5 because total we already have 2 plus 3, this will be 5. This one 2, we already have 2 and we have passengers 3 here at the location 3 from B here. So now what we will do, so we have to sum the previous total, right? So now we have to sum the this one current passengers and the passenger A as well. So this will be 3 plus 2. 3 plus 2 will lead to 5 basically, right? So here now we got 5. Total will be 5 now, right? So 5 exceeds 4. See here, capacity we have been given 4. Capacity. So here, if you can't see, let me delete this one. So we have got 5 basically. 5 basically as this one answer, and the capacity we have is 4, right? Capacity we have is 4. 5 is less than or equal to 4. No, 5 is not less or neither 5 is equal to 4, right? So this condition fails miserably. This condition fails miserably. This exceeds 4 basically. So what we need to do here, in this case we need to return false. In this case we need to return false. This is how we make use of the minimum priority queue basically, right? So here we will be making use of the priority queue or the heap to drop the passengers before picking the new ones, right? Why we will be making use of the heap or the priority queue here? To drop the passengers before picking the new ones. So before picking the new passengers we have to drop the passengers, right? So first in our case we got two passengers and we have to drop them, and then we have to sum up to the this one second one b as well. 3 plus 2 led to 5, right? So for we will be making use of the priority queue just to drop the passengers before picking the new one. So that is how we got 5, and 5 is exceeding the capacity. In the question they have clearly mentioned uh, what they have mentioned. So we must return true only if all the tips can be done without exceeding the car seat capacity, right? So this is exceeding the car seat capacity. 5 is greater than 4, so this fails, right? So we have to return false, and we got the output false here. We'll be returning false in this case, right? So the output that they have shown for the the output that we got here is false, which is equivalent to the output that they have given for the example 1 within the question, right? So our approach works absolutely correct in this case. As we are completely familiar with the approach, let's move on with the complexities part, right? So what is the complexity? Yeah. So what is the time complexity for this particular problem? So as per the approach that we discussed, the time complexity would be quite obviously because of log n log n basically, sorry. Yeah, this will be the time complexity. The time complexity would be because of n log n, right? So why the time complexity here is because of n log n? Because we are going with the sorting. We are going with the sorting plus priority queue. Also, we are going with the priority queue, and for the n trips. Also, we are going with the priority queue operations for n trips, right? So sorting and priority queue will be going with, right? So sorting plays a dominant factor basically, so it would lead to because of n log n, because of n log n here, right? So priority queue, because as I've said, we will be making use of the priority queue just to drop the passengers before picking the new ones, right? So and sorting, we will be sorting all the trips by pickup location initially, right? So these two things just keep in mind, just keep in mind why we'll be making use of the sorting, because we will be sorting all the trips by pickup location. And why we will be making use of the min heap or the min priority queue? Because we will be making use of the min priority queue or the min heap to manage the active passengers and drop offs basically, right? So just keep these two things in mind, right? So the time complexity would lead to because of n log n, and the space complexity would be because of n. So why here the space complexity is because of n? This is nothing but the space complexity. Why the space complexity is because of n here? Because heap or the priority queue stores the active trips, at most n overlapping trips, right? So the overall space complexity would lead to because of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be because of n log n and because of n respectively, right? So now we are done with the complexities part. As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So initial step is, as we had discussed, we have to sort the trips by starting location, right? That is nothing but we have to sort the trips by from passengers from to, right? So we will be sorting the trips by from basically. So I'll just go in with arrays dot sort here. This will be trips comma a comma b. This is fine. Lambda expression, this one is a of 1 hyphen p of 1. Yeah, this is fine. The next step is, as I've said, we'll be going with a priority queue, nothing but the min priority queue or the min heap, just to store the drop location comma passengers. So I'll just go with priority queue. So int this one int, so this is fine. Pq equals new. This, let me copy this one and let me paste it over here. This is fine. New priority queue. This is the syntax part, right? So this one again, we have to go with the sorting again. The same thing, a comma b. So I should have copied this one, man. This will be a of 0 minus hyphen b of 0 instead of 1. That's it. That's the only difference. So this is fine. So we are just going with the min priority queue. just for storing purpose, right? So we have to store this one, drop location comma passengers. So the next step, accordingly with the approach we are going, whatever the approach we have discussed, the same thing we are articulating in the form of code here. So let's go with the current number of passengers in the car, nothing but here in current equals 0. We have assigned current equals 0. Now let's go with the iteration part or the for loop. Initially for this one int uh, trip of this one trips. So this is fine. So within the for loop, what we will be doing, so we will be going with the passengers to pick up location as well as the drop off location, right? So first let's go with the passengers to pick. So this will be p equals trip uh sorry trip of 0. This is fine. Next pickup location, nothing but from, let me initialize this one to trip of 1. This is fine. Next is drop off location, nothing but 2. So this will be int 2 equals trip of 2. So we are done with the initialization part here. Not the initialization part basically. We are just going with the passengers to pickup location and drop off location within the for loop, right? So next, let's we have to drop off the passengers whose drop location is less than or equal to current pickup. So this is what we saw in approach. So let's try to articulate the same thing in the form of code. So let me write the simple while loop here, nothing but pq dot is empty here. This is fine. And also pq dot, let me make use of the peak operation that is provided by the priority queue 0. If it is less than or equal to from, then what we will do, we will remove the passengers who are dropped, nothing but let me consider current here equals current minus pq. I'll just make use of the poll operation, right? So this is fine. 1. We are done with the uh, we are done with dropping off the passengers whose drop location less than or equal to current pickup, right? So next after this, let's move on with the further things, nothing but we have to pick up the current trip. So here we will be going with the current equals current plus p. This is one thing. And if the capacity is exceeded, then we have to return false, nothing but here if current greater than capacity, uh, then what we need to do, we have to return false. So we have to return false. So this is fine. uh, the final step here would be we have to push the current trip into the heap or the priority queue for the future drop off. So that's what we discussed in the approach as well, right? So finally we have to push the current trip into the heap or the this one, what do we call, priority queue for the future drop off. So I'll be making use of the operation of that the priority queue provides. So this will be new int, basically we have to consider 2 and p within the flower bracket, right? So I'll just go with 2 and p. So this is fine, right? So we are done with the code almost. So we are left with only one step, nothing but if all the trips are held, if all the trips are handled within the capacity, then we have to return the boolean value true. So I'll just go with the return true. So this is fine. We are done with the coding part. So let me format the code once and let me hit the run button. So I hope this works, man. Let's see. Yeah, we are getting the sample test cases are getting passed, right? So let me hit the submit button quickly. I hope this works for all the test cases, man. Let's see. Yeah, basically all the test cases are getting passed, right? So this is it for the code. Basically, I hope the solution part is completely clear along with the approach and the complexities part, right? So for now, this is it. Thanks for watching, guys.